Hey Algebra, I know that we didn't necessarily get through all of these notes right here, but I want to go ahead and make this little video to show you kind of, let's go through this. So, a relation pairs inputs with outputs. And we know from talking about function of the day that a relation is, it's just a set of inputs and outputs. So let's keep reading this. When a relation is given as ordered pairs, the blank, the x coordinates, are inputs, x is input, and the y coordinates are outputs. And a relation that pairs each input with exactly one output is a function. And if you have a function, which by the way here we have relations, we want to know, are they functions? If you're a function, then you will have unique inputs. So like -4, do I have another -4? No, so that one's good. -3, that one's good because I don't have another -3. -2, nope. -1, 0, so guess what? All of these are unique inputs, and it basically their output doesn't really matter. And if you are like, wait, what? It was because of the vertical line test. Like if we were to plot all of those points on a graph, it would look kind of like that, okay? And that, yes, maybe there is some repeated y parts, like those 3 dots. The y is exactly the same on each one, but the x's are different. So this one is, yes, that one's a function, but this one is not a function because as you draw this line through it, it hits it in 2 spots at the exact same time. 2 different y's for the same x. So let's check this one. Oh, I just see it. This is not a function because when I hit the 6 button, it produces a 2. And that's okay. But now I hit the same exact 6 button and it produces a 4. That is not okay for a function. So this one is, nope, not a function. And it's because of that repeated input right there. Okay, so yes, there's a vertical line. A graph represents a function when no vertical line passes through more than one point on the graph. As I kind of explained right here already, there's a vertical line going through, it only hits one point. And then really what I did was I kind of said, hey, here are vertical lines going through each point. Notice there was no repeating on any of them, so we were good. Here, it repeats almost every time. It doesn't repeat right here, but oh well, it did repeat at least once, and so that's why it's not a function, right? Right. So now using the vertical line test, you basically, I would draw a vertical line. Actually, I wouldn't draw a vertical line. I would take a pen or a Post-it note or the edge of a paper, and then I would just drag it along and go, okay, as I go along, I'm only hitting one point ever. So, yep, that's a function. And what's my explanation? Vertical line test. Now, by the way, up here, I didn't write out my explanations. I was talking. You guys are unfortunate in that you don't record you doing your assignments, and nor would you or should you. But anyway, so now, okay, oops. Can I get there we go. I got it again. Now I'm dragging this line right there. It's a function. Things are nice because I'm only touching that line in one spot. But oops, ever since I let go of it, it's been touching at more than one point. So this is not a function for the same reason, because of the vertical line test. The domain of a function is the set of all possible input values. Whatever you got to do, domain goes with x. And when I said whatever you got to do, I meant whatever you got to do to try and remember that, because that's what it is. And then the range of a function is the set of all the possible output values. That's the y. Okay? Find the domain and range of the function represented by the graph. Okay, this one, here's how you find the domain. you look at just all the x values. So here x is -2, and here it's -1, here it's 0, 1, 2. That's the domain. And then the range is going to be all the y values. That one is 2, and this one is 1, that one is 0, and that's 1 again, and that's 2 again. So actually what we're going to do is we are going to say, no, we want to rewrite that to be 0, 1, 2. The range is not 2, 1, 0, and it's also not 2, 1, 0, 1, 2, okay? You don't want to repeat it, okay? And then it looks like this because it is literally just points on the graph, right? Here, though, we have a line. And so what we're going to do is the domain is the x values. Well, we basically, with the domain, you want to go least to greatest. I can't write a G, greatest. And so least starts here, greatest over here. We go this direction, okay? And then, by the way, for the range, you also go least to greatest. There, though, the least is down here, the greatest is up here, so you go up, okay? So let us find the domain and range of this. The domain. There's a couple ways we can write this. It starts at -3 and goes to 2. We can write it as an inequality. We could write -3 less than or equal to x less than or equal to 2. So now that you can see, yeah, there's the -3. It goes between the -3 and the 2 right there. So that described that perfectly. Now if we were to do the range that way, we would again start down here at the bottom, the least, and that's at -2, and it goes all the way up to 2. So -2, and now I'm going to use the y because that's our range. So this is how you write it as an inequality. Now let me show you how you write it as interval notation. Interval notation. So the domain for interval notation would look like this. It would be bracket -3, comma, 2 bracket. And if you're like, well, what the heck is that? This is kind of like when I have a less than or equals to or a greater than or equal to. If I had a parenthesis, like let's say I had it like this would be like greater than or less than. You know the difference between the equal to and the not equal to? This is like the open dot, this is like the filled in dot. Same thing with the parenthesis and with the bracket. So there's the domain, the range, okay, changed thickness for whatever reason, would look like that. All right, so there was the domain and range of that. Now we're going to determine again, is this a function? Pretty simple. There's an 8, there's an 8. Nope, not a function. Because here's what happens. I press the 8 button, it gives me -4. That's okay, but if I press the 8 again, I want to get a different, I want to get the same number, okay? I want to get -4 again, but I get a different number, so no, it's not. And if you need to write an answer, repeated inputs with unique outputs. You don't want that, so this is why it fails. Over here, function. Unique inputs, unique outputs. Okay? And if you're like, wait, what, why? None of these repeated. So it's impossible for us to have something where we're plugging in the same thing and getting different results. All right, down here, determine whether the graph represents a function and explain. So you might think, well, why don't we, graph these? Basically, they just want to test you to see if you can do it without the graph and then with the graph. You could graph these. In fact, that graph would, I think it looks like this. Let's see, 8 and -4 would be there, but 8, 4 would be there. 4, -2, for 2. By the way, there was 2 repeating ones, and then 2, 0. So that graph looks like this. So you could say it fails because of the vertical line, which is what we're about to do down here. Here's a vertical line. We hit 2 different ones. So no, this is not a function. Our explanation is vertical line test. Over here, that is a flat line. If I drag a vertical line across it, I'm only ever hitting in 1 point. So, yep, that's a function. Yes, a function because of the vertical line test. Tell the domain and range. Domain, we have -3, -1, 1, 3. That's the domain. The range is -3, 0, -3. Hang on. It's not -3. Is 2, because we're up here at 2. I'm talking about the range. Is 2, 0, 2, 0. Okay. So really, I need to rearrange these guys to be 0, 2, and that's it. Number 6. Domain. Well, we can represent it a couple different ways. So let's do this one, and let's do this one. Now, by the way, the reason I'm already kind of writing the equal to and the equal to in the brackets is because I have filled in dots on my ends. So what am I going to do for domain? I start over here and I end over here, going left to right. So I'm at -2 and then 2. And then my range, same thing, is I'm going to go ahead and use the inequalities like that and the interval notation like that. It starts down here at -2 and goes up to 2. So what's a little interesting about this is those are the same answers, but they tell a different story, okay? This one tells that it starts over here and goes over here. This one tells that it starts down here and goes up here. So just so you know, you are technically able to read them and understand that something is happening, something unique is happening. Okay, so we have talked a little bit about this because of, again, kind of our talking about function of the day. So right here, an x-intercept of a graph is the x-coordinate of a point where the graph intercepts, you'll never guess, the x-axis. So there is an x-intercept. And then the y-intercept, well, guess what? The y-intercept of a graph is the y-coordinate where the graph intercepts the y-axis. And that would be it right there. Now, one thing they point out right here is that on the y-intercept, x is 0. Now, if you are able to put this kind of in your brain as a fact and like an interchangeable, usable fact that, hey, if I plug in 0 for x, ... I get the y-intercept, then you will be able to answer like a bunch of questions going forward, because math people know that somehow students, this thought kind of flies out of their head. And so here's this very similar thought. For the x-intercept, check it out, y is equal to 0. So in theory, if I plug in 0 for y, I get the x-intercept. Okay? And then just real quick, I'll point out that we have said that the y-intercept, the letter we use for it is b. Yep, I agree with that. It's a little rare that we talk about the x-intercept being a, but it is a thing, okay? So down here, estimating the intercepts. They just want you to estimate the intercept of this graph. So 1, 2, 3, 4. Okay, so perhaps this is 4, 0. That is the x-intercept. And then this one over here, -1, 0. And then down here, well, we're pretty sure that that is 0, -4. And the reason that this is an exercise at all, oh no, I guess I'll label that, that's a y-intercept. This is also an x-intercept. It's possible to have more than one of these. It's technically possible to have more than one of these. It just wouldn't be a function, and we're kind of on this function kick right now. All right, so some key ideas about functions. They can be positive, negative, increasing, decreasing, and have end behaviors. A function is positive when its graph lies above the x-axis. So check this out. It's positive because we're above, and I'm going to label it with yellow. There's the x-axis. So we are positive on those purple parts. And a function is negative when it's below the x-axis, just like that. And then we have a function is increasing when its graph moves up as x moves to the right. So I'm going to, again, kind of keep it yellow. As x goes this direction, then our graph is increasing here. Now, notice that there's a difference. Positive is just above the x-axis. Increasing can be below, right? So it's kind of like on each of these, you are on a roller coaster ride. So here's you in the roller coaster. There's the door, I guess, to get in. And here's you. Yay, roller coaster. And your hair's flying back because it's a roller coaster, right? You are going this direction. So when it comes to like positive and negative, it's almost like this is water and positive is above water and negative is like below water or underwater, right? Increasing is, well, you're increasing up on a roller coaster, right? You know, as you're like getting higher and higher and higher. And then, I bet you guessed it, a function is decreasing. There's the word decreasing, since I'm not going to spell it all out, when it moves down as x moves to the right. So now, here it's decreasing, right? Because you're going down on the roller coaster. And then now you're going to be moving up the roller coaster. You're increasing in height again, okay? And again, it is when you're moving from left to right, all right? Last but not least, the end behaviors. The end behaviors of a function is the behavior of the graph as x approaches, now hang on, positive infinity or negative infinity. So, remember how I said you're on the roller coaster and you're going this direction? Well, if you're going to the right, you're doing this. X is approaching negative infinity. And if you were going backwards, if you were going this direction, x would be approaching negative infinity. And hopefully that makes sense, because like, think about it. Here's 0, -1, -2, -3. Eventually, I'm going to hit negative infinity, right? And over on the other side, it's 1, 2, 3, and eventually I would hit positive infinity, right? Okay, so what this graph is saying, let me erase my little circle right now, is that as x is going this direction, notice that the y is decreasing, and it appears to decrease forever. So, like if we were to write this as a sentence, as x approaches, let me zoom in here and write that word. This letter basically means approaches. As x approaches negative infinity, comma, y also approaches negative infinity. So as I'm going this direction, the graph's going down. Basically, follow that arrow. What's happening? It's going down, it's going left. Both of them forever. And then over here, over here, the opposite's happening, and that as it's going this way, it's going as x is approaching just infinity. You don't have to write positive infinity. As x is approaching infinity, y is also approaching infinity, right? It's going up, it's going over forever. Okay, so now we are going to approximate when the function, that thing, is positive, negative, increasing, decreasing, and then describe the end behaviors. Woohoo! All right, so first of all, I'm going to kind of draw our line, our x-intercept, and what I'm going to say is we are negative, negative, negative. In fact, you know what? I guess I could, okay, yeah, I can do this. X is less than 0, also known as negative, when x is between 0 and 3. Oh, okay, so I didn't really pay attention ahead of time. It's already telling us that, hey, from 0 to 3, what? It's actually negative for more than that. However, we're gonna go with what it says, right? And then it's positive over here from 3 and on, right? So when x is greater than 0. And then let's see. I guess, again, it would help if I read what I'm doing as opposed to just thinking and going, hey, I can do all this on my own. So increasing or decreasing. The function appears to be blank when x is less than 0. Okay, so what they're saying is right here is where x is 0, and less than 0 is on this side, right? So I know I'm on the roller coaster. I am increasing right here. This is you on the roller coaster, remember? Yay. So I'm increasing when x is less than 0. And let's see. Decreasing when x is between 0 and 2. And if you're like, wait, what? Decreasing here because I'm going down right there, and there's x is 2, right? So I'm going down, 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 down right there. And then increasing again when x is greater than 2, which is right, like we said, right here. We are increasing right there, yeah? Last but not least, the end behaviors. So let's go look at our end behaviors. Let's just kind of talk about them. This one is going negative infinite. This one is going positive infinite. So let's compare to what we've got here. The graph shows that the function value decreases as x approaches negative infinity. We can say that because as x goes this direction, the function is going down to negative infinity. And the function value increases as x approaches positive infinity. So this is where they kind of say, all right, so y approaches negative infinity. And this is what we said when we were right here, okay? So, and also what we kind of talked about right here. This end behavior, those two end behaviors are the exact same. So if you need to kind of go, hey, wait, what, why? Go look back at that one. Next, estimate the intercepts of the graph of the function. Well, this is a fun thing. With this one, we know that the y-intercept is -3 because of that, because this is in slope-intercept form. And the reason I mention that is because you guys have been mentioning that our functions have been in that form. So the y-intercept is there. I guess we could also write it like this: when x is 0, y is -3. And then last, the x-intercept here is going to be when x is -2, y is 0. Let's do this one since we're right here. That is an x-intercept. That x-intercept is when x is -4, y is 0. This is a y-intercept. When x is 0, y is 4. Okay? And notice this is an absolute value function. We will talk about those in the future. We've already kind of talked about that they are a parent function. They look like this. They look like a V. Fun. Yay. This is another parent function. It's y equals x squared. That's the parent. But anyway, there is an intercept. There is an intercept. There is an intercept. These are both x-intercepts. And I'm going to just write them all at once like this. And then the y-intercept, which I'll change to green, is, let's see, 1, 2, 3. When x is 0, y is 3. That is the y-intercept. And we have x, 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 and y. So our x-intercepts are, let's see, -2, 0, 0, 0, and 1, 0. And our y-intercept happens to also be the origin 0, 0. Okay, we're almost done here. Approximate when the function is positive, negative, increasing, decreasing, then describe the end behavior of the function. Cool. So here's that like little water line for the negative and positive. In fact, I'm gonna just do that negative, positive. So for negative, positive, it is positive from, and then here's where we can go back and kind of talk, how should we write this? Should we use, inequality notation, interval notation? When they talk about it, let's check out when they talk about it. They just use inequality notation. So let's do that. So it's positive here is less than or equal to 1. So that's because that's 1. And then it's also positive from 5 and on. So when x is greater than or equal to 5. By the way, this would be an OR graph because, it's over here or over here. I mean, so to speak. So anyway, but we don't need to write that. And then let's see, it is negative when it's here to here. So negative like this from 1 to 5. And you'll notice like, hey, that 1 to 5 is the same as that 1 to 5. Yep, you're right. And now let's see, we need to do increasing and decreasing. Okay, so that's pretty easy. As you're on the roller coaster, here you are. There you are, you're going this way. It looks like we are decreasing. So decreasing as x is less than or equal to 3. Why 3? Because there's the line 3 right there, right? And then it's increasing. Let's do that in green from here to there when x is greater than or equal to 3. And now the end behaviors. So end behavior is going to be kind of the trickiest one to write. It's going to look like this. As x approaches negative infinity, comma. So as we're going that way, what is the y doing? It's going up. Y is approaching positive infinity. And now guess what? As we do it this direction too, as we go positive infinity, it's also going positive infinity. So as x approaches positive infinity, y approaches positive infinity. So that takes care of all of those on that one. Let's look at this last one. Here's my x-axis for positive, negative. So it's positive here. So that would be between, let's see, that's -1 and 1. By the way, if you notice that the sound ridiculously changed, just because I'm in my classroom on the next day doing this, and it's negative down here. So let's see, that's x is less than -1, and x is, just kidding, or x is greater than or equal to 1 right here. So that's positive and negative. Now we're going to talk about decreasing and increasing. So the increasing is going to be like this. So it is increasing for x is less than or equal to that line right there, which is 1. And it is decreasing from 1 to forever. So decreasing for x is greater than or equal to 1. And then now the end behaviors. End behavior. So this one is where x is approaching negative infinity, and that's also where y is approaching negative infinity. again, we're going forever that direction, and we would be forever going down as well, just following that arrow. And then the other one over here, as x approaches infinity, y is also, oh, no, I'm sorry, not also, also because they're both of the y's are approaching negative infinity. Going this way forever, going down forever. So that should cover 3.1 and 3.2. Let me know what questions you got.